This video addresses the question, what is structural equation modeling? First, equations that are structural are those we intend to represent cause-effect connections in quantitative models. Typically, we're working with network hypotheses in structural equation modeling, such as the one shown here. Structural equation modeling, or SEM, can be thought of in a number of different ways. The first I would like to mention is as a framework for quantitative analysis. The graphic here is meant to make the point that we use statistical and mathematical tools within an SEM framework to seek a causal understanding about the multiple processes operating in systems. SEM also provides us with a means for translating abstract ideas into testable expectations. Here we show a theoretical proposition. SEM methods allow us to develop a so-called causal diagram that translates the general ideas into a network of expectations. Using the causal diagram and data, we can test the hypothesized network and therefore the theoretical proposition and arrive at a new and quantitative understanding. SEM unfolds as a process, moving from theory to model to results and eventually back to theory. This process supports generating a clarity of meaning, repeatability, learning, and building on prior knowledge. SEM is also a method for learning. Here we start with an observation that older forest stands that burn show poorer recovery after fire. We can propose and test ideas about the mechanisms behind this observation by using SEM. In this case, we explicitly test the idea that fire severity might explain all or part of the relationship between forest age and plant recovery. Stated in a different way, that older stands burn hotter and that the stands that burn hotter have weaker recovery. This is called the test of mediation. Through the use of this kind of test, we can dig deeper and deeper into understanding systems by bringing in more variables. Structural equation models also have a particular form. In these models, responses, y variables, can depend on other responses, other y variables, as well as external predictors, x variables. This equational form allows networks of relationships to be represented. SEM is also a body of knowledge. It is important to realize that there's a great deal of information about SEM, but is derived from many different scientific disciplines. History has played an important role in shaping the literature on SEM. This diagram represents a citation map showing the historical flow of knowledge among disciplines. From this perspective, we can realize how the flow of information, and especially the lack of flow of information, shapes people's perceptions of quantitative methods, as well as the language that people are familiar with. SEM is also a community of practice. There are active online discussion groups, both general and also ones specifically related to software packages. There also exist a number of working groups focused on particular scientific problems that use SEM for the solution. I hope this overview has been useful. More detail can be found in the written document summarized by this video presentation. Also, you can search for examples that relate to your subject of interest.